So I think what I'm going to talk about today is mass timber in a California context. And I think the overriding theme as I was thinking about this presentation is how much talk there is about mass timber in California and how little building there actually is thus far. So part of what I'm going to talk about is some of the examples that exist and how those projects have been approved through a relatively rigorous approval process in California, and hopefully give people some precedents to draw from to kind of further the cause in California, because I think we're certainly a little bit behind Oregon, Washington, the rest of the Pacific Northwest. For those of you who were on the tours yesterday, I heard nothing but good things about the number of buildings that are being built using mass timber and how much it's being advanced. And I think we're a little bit behind the 8 ball in California, but hopefully catching up quickly. See how this works. All right, so by way of introduction, I'm Zander Sivyer. I'm the principal and CEO of Holmes Structures. We have about 50 people in the US, in San Francisco, LA, and also Colorado. I had the boring corporate photo of me in a suit and tie on the left-hand side, but I switched it out because I actually managed to, on the way to Portland, head up to British Columbia and do a little fly fishing on the weekend. So the fish were pretty exciting, and it was as cold as it looks up there, but it was a ton of fun. So Holmes Structures is part of Holmes Group. We have over 10 offices and over 400 people spread across 3 and really 4 countries. I think I'm missing another dot on that map. It needs updating. But we have a pretty heavy focus on structural engineering, but also civil engineering, fire engineering, product testing, and development. A colleague of mine, Bevan Jones, is, I think, presenting in the other room on some of the evolutions in the fire code in California and beyond. So there's a depth of knowledge there to draw from in our context. Okay, so what I'm going to talk about today, as I mentioned, is a California focus, a little bit of history on buildings that have been built in California and some of the code evolution, and then spend a little bit of time on 3 projects that Holmes Structures has been working on in California, and then look at what's next. No one needs much introduction into what mass timber is in general. My, I guess, presentation focuses more on the CLT, NLT, DLT flooring systems and potentially shear systems in buildings than what has been really the more traditional kind of glulam, LVL type products. So we'll kind of run through all of those. It's baby steps in California. I kind of tried to do as much research as I could in terms of mass timber buildings that have been built. I got to a grand total of 8 in California, and 4 of those were completed last year. There's one building in California that we'll talk about that's all mass timber CLT building. That's the Plumas County Biomass building. Actually, the client for that at the Sierra Institute is here, so thank you very much for being the first. But there's a hell of an opportunity there. I think where the sweet spot is for mass timber, it really falls in line with a lot of the buildings that are being built in California and a lot of the buildings that need to be built both at a commercial scale and also a multifamily residential scale. So I would expect these numbers to change rapidly, but it is interesting to see just how long it's taken to gain any traction and actually to get projects built. So part of the history, I think if you looked at mass timber buildings in California, this is a picture of Cooley Landing, which is not one of our projects, but designed by KPFF up here in Portland. Was about the only example you could find of a mass timber building in California for a number of years. And up until really the code change that occurred January 1st of this year in the California Building Code, CLT was not in the California Building Code. I think part of the earlier talk this morning mentioned an adoption into the code in 2015. It still took until January 1st of 2018 for that to make its way into the CBC. Before that time, anything using CLT needed an alternate means and methods request and running through the permitting agency. After January 1st of this year, we now have CLT in the CBC. Only for gravity load applications in its entirety. Anything that uses mass timber or CLT as part of the lateral load resisting system, the floors, walls, diaphragms, still needs an alternate means and methods request. So there's still some challenges there, and it requires kind of a lot of incremental advances, especially with building officials, none of whom want to be the first to approve anything new and different in California. So I think part of the difficulty we've had with some of the projects that we've pushed through have been to point to other project precedents and where it has been approved elsewhere in California. So part of the thrust of this is maybe to illustrate some of those projects that have been approved, and hopefully collectively we can kind of push the needle forward. One example is a project that recently topped out. It's in Brentwood, California, which is in the East Bay of the San Francisco Bay Area. It's a public library, a little over 20,000 square foot building, two-story building, CLT floors and roof, and that's actually composite CLT with a concrete topping slab on top of a structural steel frame that's both the gravity and the lateral system. So it's a structural steel moment frame system. Type 5 construction, so easily permittable through the code. It was, however, the first building in California that used CLT compositely with concrete, so that took just a little bit of getting through the local authority, but they were okay with the first principles justification for the use of CLT compositely with a concrete topping slab. There's some photos of the CLT panels going in. It was a really great example of kind of speed of erection. I think the steel frame and the CLT went in a period of weeks. It was really exceptionally done. I think the CLT for this project was supplied by Structurelam, who did a great job kind of working with us on all of the structural detailing going in. So the panels, I guess the hardest part with taking photos of these is that the trucks started turning up at 6 or 7 o'clock, and if you weren't there by 9 o'clock, the trucks were empty, all the panels were installed, and people were waiting for the next shipment the next day. So it was really quick going. And this is the kind of CLT in all its glory. On the underside, the soffit of these areas will be exposed in the final condition of the library. The next project that I'll mention is the Plumas Health and Human Services Biomass Boiler Building. It's a grand total of 2,400 square feet, and maybe I'm rounding up to get to that number. But it is a one-story building in Quincy, which is a little, I think, east of Chico. It's entirely CLT structure, CLT walls, CLT roof slab. It took a while to convince building officials that this was okay, and I think we actually drew a lot on the statewide ordinance in Oregon that has a published R value of a whopping total of 2 for CLT systems, and so that was able to be deemed code equivalent for the permitting agency. So that did give us some traction, but I am looking forward to some of the evolution in those R values and seismic values. It works well when you're one story and 2,400 square feet, but I might stretch to go any further. It was about as simple a CLT building as you could get and came together really well. Just a single span 3-ply CLT roof on top of CLT walls and a concrete foundation. And that's it. I think it's completed, topped out, and should be open shortly, if not already. A couple of weeks. Cool. The last project I might spend just a little bit more time on. It had some more challenge and certainly is the biggest of the 3 projects. This is a corporate campus in Mountain View, California, so kind of in the heart of Silicon Valley. It is a large endeavor. It's about 650,000 square feet of office, and there's about another 500,000 square feet of structured parking. That office is a combination of new structure. There's shade under 500,000 square feet of new build mass timber building there, integrated with some existing repurposed office buildings. As you can tell from the rendering on the side, the entire roof of the new office building structure is going to be a green roof and accessible to all the employees. And so there's some pretty hefty structural loads up there. It's at least 200 pounds a square foot in dead load, and then 100 pounds a square foot in live load because it's all accessible. I think there's even some areas where that loading goes up. The landscape architect had a grand vision of having an orchard on the roof, so there are some significant fruit trees in the middle around the cafe. And like any good tech campus in the Bay Area, it also has an Olympic-sized soccer field and a couple of basketball courts and any of the recreation and amenities that you could ever wish for, so people never have to leave, I think. This construction type was a type 3B. It took a little bit of gymnastics from the architect to get that through the City of Mountain View, but it did get approved as an alternate means and methods request. That really gave us a lot of freedom on the structural side. The structural system is, again, a hybrid in nature. It's CLT floors that are composite with a concrete topping, supported on steel beams, which are then supported on glulam columns. So kind of a combination of a whole lot of different things, but all of which were integrated in the architectural design as a build-to-suit campus for an end-user client. The lateral system was a concrete shear wall building just with a mass on that roof, and also the risk aversion from the client with regards to potential issues holding up issuance of a permit. We have essentially a CBC compliant lateral load resisting system that has those concrete shear walls and then the CLT compositely with the concrete topping slab as the floor diaphragms. So I wanted to just spend a little bit of time talking about some of the challenges and how we navigated those through the code. Before I do, I just have a couple of pictures of what some of the interior of that space will look like. The design brief from the client was for the large size and scale of this project. They really wanted to create a more, I guess, a human scale feel for the occupants in that building rather than a kind of generic tall steel and glass corporate building. So hence the kind of drive for natural light and exposed structure and the use of wood as a key part of that. They also have some pretty lofty sustainability goals. They were looking at a net zero building. They wanted a net zero water usage, so that green roof collects all the water for the campus and recycles it with holding tanks on site and through the campus, so it should be net zero energy and net zero water usage, which is a big deal in California after a number of years of drought. And the wood material obviously was a big part of the sustainability story for the client, being the embodied carbon really made a significant difference. There's some open malls, and I'll talk a little bit about that as to how the Type 3B system worked through. And then all of the office space has both access to natural light and exposed wood in the glulam columns and also the soffit of the CLT floor slabs with limited coverings up above. All right, so some of the challenges, this is kind of a floor plate showing it, and some of the kind of cuts you see through the middle of the building really created separate diaphragms which allowed the building to be treated as a Type 3B building, and it was really defined as a mall concept, kind of similar to a shopping mall with kind of areas of enclosed space and then areas of open space. That took a little bit to get through, but really enabled a lot of flexibility with the materials. We then stuck with a code-compliant lateral system and that hybrid flooring system, which was able to be justified again through first principles. A big challenge on a project of this scale for us and the whole design construction team was looking at procurement. There's just a large volume of wood on this project. Some of the stats from our friends at Structurelam who ended up being selected to provide the wood on this. There's 160,000 cubic feet of CLT panel, 21,000 cubic feet of glulam columns, and a really tight time frame to turn that around. We have 6 months of pre-construction that we're mostly finished with, about 5 months of production, which is about to start, I guess, hopefully within the next month or so, and then optimistically a 3-month install. So thinking about that with the construction team was really a big part of the procurement process, because in looking at that volume of wood for all of the potential new supply that's coming online and will come online, there's a lot of suppliers that can't produce that volume of panel in the time frame that was needed. The general contractor at the time reached out to a firm up in Vancouver, Aspect, who helped with their procurement process. And this was actually really valuable in terms of just identifying the production capacity of a lot of the suppliers in the Northwest. And also it kind of opened it up to some of the European suppliers of wood panel who produce much greater volumes of wood. So there was a really thoughtful and deliberative process that kind of went through this procurement to make sure that we selected the right partner. And as I mentioned, that was Structureland. Yeah, it was a hugely valuable experience. Maybe some of the other challenges, as we worked through it, I would say that for all the thought that went into that procurement process, the wood supplier was kind of the last key player on board in the team, and they got selected right about when we were done with the permit set of drawings. So there's a lot of detailing done, and I would say that looking back, it would have been great to have had their input earlier, and that would have saved a lot of kind of redoing of things to help speed the production process after the construction drawings were done. As we went through the design and pre-design process, we had a contractor on board, but as I mentioned, just the state of the industry in California, there's not been a lot of buildings built with mass timber. And so there was really not the depth of construction knowledge that you might hope for, and I hope that will change. A lot of buildings of this scale in that part of the world get built as structural steel buildings. And so there was a big push to kind of think about, it's like, yeah, we want to do it in wood, but how do we make sure that we can build it like we do a steel building? And so there was a little bit of gymnastics around getting the detailing right. We iterated a lot, and we're really happy with where we ended up. As structural engineers, we don't often get to drive aspects of the design, but we kind of took this one on board and we actually used SolidWorks to kind of render out all of the different connection details that we could come up with, and then iterate with the contractor and also the wood supplier once they were on board. Some of the big questions that were getting asked during the design process and that procurement process is who's going to take responsibility for the whole thing in what is currently a traditional GC role. They often look at essentially subcontracting everything out. So between the wood package, the steel package, the concrete package, you have 3 different trades involved, and who's going to take responsibility for the structural frame? So I think that was another issue that drove it, and who was going to bond the structural frame was a big deal. And I'm really excited to see some of the folks from Swinnerton talk about their project and kind of the approach that they're taking, which is maybe a little different than what we experienced on this project with kind of multiple subcontractors and trying to work out exactly where that responsibility sat. All right, so what's coming up, or what are we looking at? I guess personally, I'm most excited to see some of the talks at this conference about some of the testing and development that's going on with regards to R factors and ductility factors for the use of CLT as lateral systems, some information that we as design professionals can draw from in the design of new structural systems. I think there's actually, there was a great kind of the end of the presentation this morning talking about some of the changes to the building code with regards to the types of construction available to us, that type 4, A, B, and C is really exciting to see progress. And as I mentioned, my colleague Bevan Jones at Holmes Fire has been really intimately involved in that, and I think it's going to open up a lot of opportunity for taller buildings and also more easily approvable buildings, certainly throughout California, but all over the country. I think there's a lot of work that's going into looking at mass timber and prefabrication, whether that's prefabricated buildings or components of buildings. Certainly the folks at Katera were talking about that this morning. We're also working with a different group of folks in the Silicon Valley who are looking at R&D efforts on prefabricated mass timber components and building components, and how to find out where the sweet spot is relative to traditional forms of construction, where it makes kind of economic sense. And I think that's really going to tip the balance in terms of where that gets used, a code change and some real definition on economic viability with, I think the key is going to be general contractors who understand how to build mass timber buildings and can price that accurately as opposed to price the unknown, which is maybe what it has been to date. I think that's really going to change things. So I'm excited to see what happens. I think every project and every individual is probably at a different stage of the adoption curve, but hopefully most people here are past that trough of delusionment and on to the slope of enlightenment, because it'll be fun to see what happens next. Thank you.